Hello everyone. So what I'd like to do here is describe how we think about three-dimensional graphs. Three-dimensional graphs are a way that we represent a certain kind of multivariable function, the kind that has two inputs, or rather a two-dimensional input, and then a one-dimensional output of some kind. So the one that I have pictured here is f of xy equals x squared plus y squared. And before talking exactly about this graph, I think it'll be helpful if by analogy we take a look at two-dimensional graphs and kind of remind ourselves how those work, what it is that we do, because it's pretty much the same thing in 3 dimensions, but it takes a little bit more visualization. So with two-dimensional graphs, you have some kind of function, let's say you have f of x is equal to x squared. And anytime that you're visualizing a function, you're trying to understand the relationship between the inputs and the outputs. And here, those are both just numbers. So, you input a number like 2, and it's going to output 4. You input -1, it's going to output 1. And you're trying to understand all of the possible input-output pairs. And the fact that we can do this, that we can give a pretty good intuitive feel for every possible input-output pair is pretty incredible. And the way we go about this with graphs is you think of just plotting these actual pairs.
So let's take that same idea and go up a dimension. And what I'm going to do now is I'm going to consider functions of x and y with an output of z. That is, there are two different inputs, the x and the y, that get fed into my function, and I still only have one output z. In this case, I'm considering the function z equal to x squared plus y squared. And it's going to look a little bit like this, and we're going to figure out how to think about this, how to come up with this shape a bit later on in the video. Now, we live in three-dimensional space, so it's easy to visualize stuff in 3 dimensions like this particular surface here. And it's easy to represent mathematical objects in 3 dimensions. It's quite reasonable to have functions that depend on more than just x and y. For example, maybe your function depends on x and y and z and t and who knows, any number of other things. It's also fine to have outputs that are higher dimensional as well. You could have an x and a y and a z that all change based on different types of inputs. Now there's one nice thing about having 2 inputs and 1 output, is that the sum of 2 and 1 is 3. And this 3-dimensional graph, well, we live in 3 dimensions. We can visualize things in 3 dimensions. It's possible to have more inputs. And it's also possible to have more outputs. That's all entirely okay. It's just you can't graph it quite as nicely in 3 dimensions.